Guys, we're going to go live now. All right, welcome back. We are Game 3004. That's Mobile Game Dev 2 in the winter 2022 semester at George Brown. And it's week 13, part 2 of our broadcast and recording. And we talked last day about a couple things, stuff that's due. We said that final release is due next week. Final presentation will be due the week after. I've given you guys details about that. This week we're talking about memory profiling and Q&A testing, which is what we're doing right now. And stuff that we're going to be doing is performance profiling. Lab 9 is a group lab that you're going to be doing with you and your group. So you'll be doing two things. What I want you to do is, for your performance profiling, is you're going to run through the tutorial. You're going to capture before and after snapshots of your performance, but you're not going to be using my lab. You're going to be doing this. You're going to use this for your final release. And so you will use your project, as a testing target, right? Because that's what you want to do. That's what you're testing. And one thing that we're going to note is this is a group lab, so that means only one of you from your group needs to submit it and do your small video and all that stuff about your performance profiling. So that's the difference between this lab and the other ones. There are going to be two group labs this week and next week. All right, so that is what's happening. Without further ado, let's get to our project and see where it's at. So we're going to start with our, from a scenes perspective, let's start with our procedural scene. Okay. And our procedural scene, if you remember what we did last time, was when we ran it, right, then we had this, where we had this stuff happen, which is not bad. And if I press R, when we can regenerate our scene over and over again, and we have some issues, like some of this stuff happening, which isn't that great. And that shouldn't be happening. We're going to fix that today because we had some problems with our code, and we're not going to let that happen as much. This shouldn't be the case for your scene. We have these holes. Why are the holes happening? I'll talk about why in a second. All right, so wonderful. We have this stuff, and we did a bit of a build and run last day. So if I said build settings, our build settings, we should switch to Android. So if you haven't switched over there already, and let's switch platform. And what we want to do, like we did last day, was set up our development build. And we want to auto-connect the profiler and do set up profiling as well. So this is the other thing we're going to click on as well. Okay. So again, I'm just retargeting Android just to make sure we're on the same page. I'm going to also fire up LD player while I'm waiting, just to make sure that this is all ready to go for us. And with LD player, the project I was working with with the first team, I'll talk about it. This one. So that's the one I want to work with you on, right? And let's go back to this as it's converting over to Android. It's almost switched over. I have to give it a second. One thing that I'm going to be doing is trying to do a couple of optimizations. What we want to do is we want to pull up a Word document, a blank Word document. Let's do this. So I'm going to bring up Word. And this blank Word document, I'm going to make this the kind of profiling report. So file, I'll say save as, and we'll call it the profiling report. So instead of downloads where it's supposed to go, I'm going to choose a different spot. So this is going to be on our desktop. So let's browse for that spot. On our desktop, inside of this, I'm going to go to Game 3004 and look inside of section 401, inside of Lab 9. I'm going to put this inside of assets, and there's going to be we'll make a docs folder, docs, and we'll put this doc in there, and this will be a profiling report, performance profile report. That's what this is, and we'll save that in there. Right now it's an empty Word document, but we're going to get into that in a second as it's doing its thing. In the meantime, let's go back to Unity and make sure that inside of our development build, we click on development build. We also click on AutoConnect Profiler and deep profiling support. We want that in there. Okay. And the other thing that I want to do is let's go to player settings and make sure that that's set up. Again, this should say, just like last day, Lab 9. Everything else should be the same. This should say Lab 9. Please make sure that it says Lab 9 and not Lab 8. Again, this you're not going to use Lab 9, but I'm using this as an example project for you. You are going to be using your project, okay, the one that you're using. So on docs, you can see that there's nothing there, but that's okay because we're going to save it in the same spot, okay? So what I want to do now is I want to get a baseline. So before we do any changes, we want to start with a baseline. So let's type in, this is our baseline, right? And we're going to kind of zoom in here. And in our baseline, we're going to get a snapshot of what our memory looks like right now. So the way to do that is we're going to do a build and run. It's going to ask us where. I'm going to put it inside of our builds folder. And inside of our builds folder, we're going to call this Lab 9 and click Save. And what this is going to do is build everything. I'm going to spark out in a second. And after it builds everything, it's going to start the performance profiler right away. What I'm going to do is I'm going to use a screen capture tool to do this capturing. I'm just going to use ShareX just to capture the an image of the profiler and see where we're at. So again, I'm just waiting for this to finish building. You can see it takes quite a bit of time. If everything goes well, then we should be ready to go. Wow, this taking a while. 3 minutes. Hopefully you guys are already built and ready to go. So a couple of things that I want to do is also take a look at the console. And after the console's done, after this is done baking, the console also has some information about a build report. And we can see what the build report tells us in terms of our textures and a bunch of other stuff. We're going to capture that information too. Okay, it looks like we're getting closer. Typically, this takes a little longer because of the additional tooling that we're asking to be completed. So again, bear with us as we get through this part. And we're in the post-generate process, which is kind of at the end. I'm so sorry, Herman. I know that I'm kind of sparking out here because of we're building. Bear with me while we do this. Okay, finally. So yeah, so what it's going to do is if you look through here, it's trying to generate my first tiles, and it's taking its time doing that, right? And you can see that there's no performance profiling right now because it's still trying to generate its first scene. And that is an issue. That's taking a lot of time for us to see anything right now in this part. Right? It's going to take a few minutes to do that. A lot of times it might take up to a couple minutes just to generate or regenerate the scene. In the meantime, while we're waiting for this to start, I'm just going to go back to the Unity side of the house and go to the console and go to where it says these ellipses, and this open the editor log. And if I control F it, go to build report, we can find the build report, and the build report gives us some information that we want to capture. So I want to capture this part. So I want to say that the build report from the log gives us this initial information. Okay, this is kind of telling us some stuff about where the issues are in our code, where it takes up a lot of our resources. And I want to kind of come up to about right here. I mean, we could go further, but these ones are like 1K. So there's nothing really crazy about this. In fact, the ones we really care about are in the hundreds. If it's only 50K or whatever, unless it's something that's being used over and over again, then it's probably something that is not really that important. But all this stuff, all the way up to about here, let's get that build report and pump it into our thing. So this is the build report. And this is, we'll say, the initial build report. And just kind of copy that in there. We can also extend these margins. We don't need the margins to be so narrow. So try that again. And same thing goes with over here. We can make these margins a little wider because we're going to save this thing to a PDF anyway. All right, so that is the build report. You can see that the textures and all the stuff what we have. We also have a lot of spacing. A lot of times that comes out with this because we're just copy pasting. So again, we can kind of go in here and we can change the spacing so that it can fit into one area. So I want to go into line spacing as 1. Is that correct? Still pretty big. Yep. Outside, inside. We will not mirror indents, sure. We want 0 and 0. And line spacing options is single, and press OK. And that should be a little bit better in terms of trying to fit into one page or so. I think this is a good thing. Again, I want to just to make sure that this is, I don't want any margins for this one. It's just formatting, but I want to capture this because this is our first kind of kick at the can in terms of everything that we have to do. I'm just going to move this over so we can have a lot of space, and that should mostly get everything in here. So these are the main textures, and notice that the number one thing for the most memory is textures. So this is something we can highlight. Textures is big for our build report. And it is uncompressed by category. Sounds is 0, so we don't really care about sounds because we're not using sounds right now, so we can remove that. Shaders is 2.1. This is kind of a little table that we can put in here. So shaders take up a bit of space more than anything else. Levels, not really that important. Scripts is not bad in terms of spacing. Included DLLs is 0. We don't have to worry about that. File headers and total user assets is 14.1 for a total complete build size of 573.6 megabytes. Okay, and these are the areas that are specialized. I really want to take a look at these two things and see if there's anything we can do. And notice that those two things are the universal render pipeline shaders that we're using, and the Liberation Sans SDF asset for our Text Mesh Pro, 1 meg. Again, it's not huge, but again, those are the areas that are bigger. And then these are all the textures that we might be able to reduce for the stuff that we're working with up until about here. So this real area here is the stuff that I want to modify. The other stuff are things that I'm not really doing, and there's no control. I can't change the this stuff too much because again, we're in the 256K range. It's pretty good. The rest are very, very small. So I'm just going to erase everything just to focus on those areas that I want to reduce as much as possible. So that's up to about here. Okay. So that is our build report, our initial build report. Let's do our baseline now. So baseline is what we want there. And we're starting to collect information. We don't need that anymore. And let's get back into Unity. We can see that this is running now, and we can see that we've run our object here the way it is, right? We can move around, and when we do so, I'm just going to make this a little bit smaller so we can see what happens when we do. When we move around, I'm just going to move this up here. Then once we do that, we can see that some of these things drop off. Now, I've turned off some things. So I want to talk about the way this works. This is actually recording right now or getting data, right? So this is profiling. I've turned off, from a profiling modules perspective, GPU isn't giving us anything. So I've turned that module off. This is the way you turn it off on the top. I've also turned off audio and video because we're not doing anything there. Physics 2D, we're not touching. Networking, we're not doing. UI is very, very small. Real-time global illumination is nothing. So all of these things we've turned off. And the reason why we've done this is because the real things we're caring about right now are CPU usage, rendering, which is draw calls, memory, and physics. Those are the only ones that really count for us for this project, okay? And we can see that we're getting some numbers in terms of memory usage and a bunch of other stuff here. We want to, again, capture some motion. So we want to get a baseline for what happens when we're playing the game kind of thing. And so if I move around, like I said, again, and I move and I turn and I collide and all this kind of stuff in here, and I put up my mini map and I run through it and I turn my mini map off, we're going to get some usage. And now this is a great place to stop recording. All right, so something around this here. And notice that I have some information. If I click on any one of these things, let's say, for example, I click on the top one, then on the bottom, you're going to get some information in terms of the job, the render, the process, all that stuff that's happening. And this is, we're stopped for frame 1160, 11,680, right? I can also kind of zoom back and look at any other frame. This is a kind of a 300 frame range that we're looking at from, again, frame 11381 to frame 11680. So again, 300 frames that we're looking at. And we want to kind of look at just these frames here when we're taking a bit of a hit. You can do it inline right here. And it talks about the memory utilization, texture memory, which is about 118.9, total used memory, which is 175.3 megabytes. I could also look at other things like mesh memory count, but it's pretty low. That's why I've discounted it. Material count, 68, materials. Object count, we have something like, again, 16,000 objects. GC use, this is not a bad thing. Actually, we should probably keep this on. We didn't do that the first time. Physics used memory, 6.8 megs. And we can move this down a little bit. Overlaps, that's kind of our collision detection. We can also look at trigger and discrete overlaps, continuous overlaps, and physics queries. If we click there, it also tells us things like how many static colliders do we have? 2,759 static colliders. One physics query is what we did at this particular time. Again, if I look at total memory, doesn't tell me much. Rendering is interesting. It tells us how many draw calls, 4,500 draw calls, and triangles, 55,000 triangles, and 112,000 vertices. And it kind of talks about render textures as 108 megs. Okay, so that's something that we can look at to change. And I think this is a good thing to capture. I'm going to capture the screen as is. And the way to do that is I'm going to use our ShareX, but I'm going to do the way I'm going to do is I'm going to press Control Print Screen, which can allow me to kind of capture the profiler. So really what I want to do is I want to capture the details. I'm going to go all this and maybe to about right here. And then I'm going to take that and populate it inside of my baseline. So this is something that I'm putting in, and this is going to hold my baseline data so I can compare it with what I get in the future. And let's undo that change. The biggest I can make it for this one. All right, so that's my baseline data. So what I want to do is make a change and see if I can kind of reduce some of make the results better than what it is right here. Okay. One thing to also take a look at is scripts. So scripts, the effect of scripts on the performance and CPU usage. Physics, low. Animation, nothing. No animations, of course. VSync, big, right? But it's in line with what we're doing. It's kind of like global illumination, nothing, minimal. UI, nothing. Others, very small. So the only thing that really cares about is scripts and rendering, and really I only care about rendering for the most part. It's really low. Scripts is also a big one, and if you really care about that, you can put that in there. You can also rearrange the order of these things and everything else. Okay, so now that I've seen this and I've kind of made my capture as much as possible, it tells you how many milliseconds of time that the CPU time that this captures, all right, per frame. And this is the frame average. Let's see what I can do to make this better, all right? So I'm keeping the same settings like we did before. These are the settings. And now I want to capture it again with making some changes. So again, going back to this, we can stop this altogether. We can kill this and close this. There we are. And now let's think of an easy change we want to make. In our map generator, we have I'm just going to go to scenes, and I'm going to go to, scripts, and I'm going to go to our map generator script for a second. And in my map generator script, what I want to do is think about putting together the first thing that I would do, of course, with all these different files is I want to put together an object pool. That's the first thing. So let's see how object pool makes a difference with what we're doing here. So right now I have, let's say up to 64. I think we changed this last time, but I changed it back. Let's give ourselves a little bit more range. I'm just going to wait till ReSharper kicks in for a second. Move this to 128. These are just options. We can check if we have time. We'll check different range options and see how that affects our performance. And we have our list, and we have our start. And what we're going to do is we're going to make a new private to support our insanity of the object pool, right? We're going to say let's make a new queue of type GameObject, and that new queue is going to be the pool that we want to make. So this is the optimization we want to look at first. And what I want to make in the first thing is I want to build my pool. I want to make this a private void build pool method. And when I build my pool, it's going to look like this. Pool is equal to a new queue of game objects, right? And I'm going to do a little for loop. And I'm going to go for I is equal to 0 to, let's say, something like, I don't know, let's see, how many objects do I need? So imagine if I'm doing a 16 by 16 by 32, right? Then I would need like 8,000 objects. What I'm really doing is 16 by, I'm testing with 16 by 32 by 32. That's like 16,000 objects that I need, 16,000 tiles. I may not need all of them, but I may need up to 16,000 tiles. Let's say we're going to go to 20,000 tiles to start in our pool. Okay. And what I want to do here is I want to create a tile. I'm going to use this create tile function again and again. So that's what I'm going to do here. So that's what the bullet pool is going to, or the pool is what it's going to keep calling bullet pool, but it's not a bullet pool, it's an object pool. My create tile function, and let's actually put that before our build pool. How does create tile look? Well, it's as you would expect, private void create tile, and create tile is going to have a var tile, which is instantiate a new 3D tile. That's our prefab with vector3 0 by default and quaternion identity. Okay, so that's going to be what we're instantiating. We're going to tile.set active to false because we're not going to make it active until we call it. We're going to say that the tile.transform.set parent, we're going to set the parent to the tile parent. That's where it's going to go. And then we're going to onQueue the tile. OnQueue actually adds the tile to the queue. So that basically adds the tile to the pool. That is create tile. So that's what this does. Every time we call build pool, it creates a tile. And we're going to call build pool before we generate. So we're going to say build pool first. Okay. All right, so we build pool. We've got our pool, but now we're going to have to get some tiles from the pool. So there's going to be two functions. One of them is going to be a get tile. Let's code that. Private game object. It's going to be called get tile. And we can specify in the tile that we want a vector3 position where we set the default position of a new vector3 object. Just in case the user doesn't want to give us a position, we can just kind of use 0, 0. And what we can say is that game object tile is equal to null. So we start off with no tiles. If my pool.count somehow, let's say I run out of tiles, is less than 1, I don't have enough tiles in the pool, then what do I want to do? I want to create tile. That's what I want to do. I want to make another tile and put it inside the pool. Okay, that's what create tile does. It onQueues a new one. Okay. If I need another one, it'll add another one. So what this does is check if there are enough tiles in the pool, and then if not, then add one. Okay. And then what I'm going to say is my tile is equal to pool.dequeue. So I'm going to get a tile from the pool, right? And then I'm going to say tile.setActive is true. Let's set it to true. And let's position it where we need it. Tile.transform.position is wherever the position is by default, right? The position that we're getting up there. And then we're going to return that tile out so that we can have a way of getting that tile out of the pool. Okay, so that's our get tile function. We've seen this kind of stuff before. And finally, our release. We're going to release our tile back to the pool. We're going to take that game object tile, and what we're going to say is tile dot set active false, and we're going to pool the pool dot on queue tile. Okay, so those functions, get tile and release tile, are going to replace instantiate and destroy. We don't want to use instantiate and destroy anymore in our code. We're going to use our tile. We built a pool. We generated we're going to generate. And what generate does is it goes through and it initializes, it resets our map. It regenerates the tiles and removes internal tiles and positions the player. That's what it does right now. So there's some issues here that we're going to fix in a second. And the way it's going to work is when we regenerate, instead of instantiating a new tile, we're not going to do that. We're not going to set the parent. We're only going to add to the grid. That means we can get rid of this piece. Let's get rid of it. And it'll look more like this. var tile is equal to get tile, right? We're going to get a tile. We're going to make a new vector3 object. We're going to pass in x, y, and z, right? Where x, y, and z is the new tile that we want to put in there. And that's all we really need to do now. So that's going to give us a new tile, and that tile is going to be added to the grid. Okay, that's instantiation is going to be replaced by our new tile. Position player is not going to change. Reset map, that is definitely going to change a little bit. Instead of destroying the tile, we're going to release a tile to the from the grid back into the pool. That's what's going to happen there. So that's the difference with that release tile. Okay, nice and easy. We don't have disable collider. That is in there, but we're not using that right now. Let's just get rid of that function just to clean up our script a little bit. We don't need this right now, as we're going to remove internal tiles. Really, remove internal tiles is like pruning, where we can prune the tiles away from what we're doing. And the way this looks is we have a normal array. We talked about this last time. But what we do is we loop through each of the tiles, and then what we do is we kind of count up how many normals we have, and if we have more than 5 collisions, that means that every face is kind of put together, then we want to remove that tile. So let's go here, and instead of removing or destroying, we're going to release the tile from back into the pool. Okay, so we replaced instantiating and destroying with get tile and release tile. Okay, any questions around this process? What are your thoughts around this? Like a regular bullet pool or a regular object pool of any other type, this is the same thing. I've just put the object pool inside of this one little class for testing. Let's try this out and see if it works in our scene. So first thing, we want to test locally. So here's our scene, and I want to run it. And let's see if it actually is working now the way it worked before. So run. And we can look at let's take a look at our map generator, and we see that no, in fact, it did not work. Huh? Wait a minute. How come we're not removing any tiles? That's 9,000 tiles. We started off with like 2,000 tiles. If I regenerate that, if I press R, you can see there's 9,000 tiles again. R again, 4,685 tiles. Wait, what the heck? R again, and there's some problems. Why are we getting these holes? This is the same thing we were encountering last time, where depending on when you press the R button and how it works, we get these really weird holes in our scene. Well, why are we getting these holes It's because of the order of execution. Let's talk about this a little bit. So what we're expecting is once we build our pool, we have our pool. That happens only one time in the start function. And then what we're doing is every time we call generate, what's going to happen is it's going to follow this thing exactly, right? It's going to follow initialize, reset, regenerate, blah, blah, blah. Reset, let's go to reset. Make sure that this is a release tile. This is what's happening. But what's happening actually is that when we regenerate, right, and I'm removing our internal tiles. How many internal tiles have we removed? Well, that's the first thing we should check. Let's go into that, go to definition. And inside the internal tiles, let's output how big is the size of the tiles that we're removing. So let's do that. So we'll say debug.log, and we'll say, debug log, and we'll say number of tiles to be removed is plus size, whatever that size is. Let's see how many tiles should be removed from the scene based on the numbers that I just rolled. So going back to this, if I run it, we should have like, I don't know, 3,000 tiles here, but actually what we're getting is 8,000 tiles. Why? If I look at the console, number of tiles to be removed, 0. Huh? What? How is that possible? Well, it's the order, like I said. So what's happening is, let's go back and take a look. We're saying regenerate, okay? And regenerate is doing this part. We're adding tiles into the scene, right? We're adding tiles, adding tiles. Guess what? When we're adding tiles, right, it's taking more time to add tiles to the grid, and this is happening in the background when we're getting a tile and so on, right? All this stuff is happening in the background. And what's going to happen is when we're trying to remove internal tiles, it needs some more time to, it needs more time to do this kind of stuff as we're counting and rate casting and everything else. So the right thing to do is delay somehow, right? And there's ways to do that. We can split these functions up into late update and all this kind of stuff as well. However, what I want to do instead is I'm going to invoke, I'm going to use the invoke function where I can call the remove internal tiles function with some kind of frames. Let's say we wait a couple of frames. So 0.032f. That's we're waiting a couple frames to invoke the remove internal tiles function. Let's see if we do that. What changes does this make if we did that, if we're invoking this wait period? So first we're waiting for things to regenerate, and then we're removing the tiles. It's almost like we haven't waited long enough. There's thousands of tiles to put into the scene. And even adding them to the scene graph is taking so long that we're trying to remove stuff that doesn't exist yet. Okay? So if I save this, and if I go back to here, and let's take a look at these numbers again. If I press play, then sure enough, our numbers are still, oh, look at that. It went down to 2,914. Okay? 2,914, which means if I was to look inside the scene and I zoom around in the scene itself, I kind of zoom inside the middle of it, you can see that the tiles have been nicely removed again. Nice. Cool. And if I press R again, then I put them back. I take them out again. No holes, right? We don't see any holes so far. Again, no holes. Again. 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 We can see that there's no holes in the scene anymore, even though before we had them. And the reason for this is because we just weren't waiting long enough for us to remove tiles, right? That's what was happening, right? So the order of execution was just killing us. All right, so now that we have our little bullet pool or object pool in place, equivalent, and we have this thing working. We're waiting exactly or approximately 2 frames. So waiting about 2 frames, right? In order for us to remove tiles, internal tiles. So we're regenerating. This takes some time. We know that. Resetting the map also takes some time. We could also wait for the map to be reset a frame before we do the regeneration if you want to. That's also can take time, right? And again, you can also change these functions so that they get hit in different order. But I like the invoke function. It's only going to get called once because it's got an if statement there. All right. Let's try this out and see if it works. Let's build this now and see if we have an improvement. Let's see what happens. So build, file, build and run. Let's see what happens now. What are your thoughts, guys? Herman, Mandeep, or Michael? Do you think it's better? Do you think it's going to be better? Do you think it's going to be worse? What's your prediction? I think you're probably right, Herman. So Herman's guess was CPU might be better, but memory would probably be worse. Okay, let's see. Why? We're pre-allocating 20,000 tiles, guys. That's what we're doing, 20,000 tiles. And again, it's based on what this memory allocation is, right? Whatever these numbers are what we're allocating. All right, cool. We've built it, and let's see what it looks like. As it's building, Unity starts off, and well, here it is, but let's start recording. Let's make sure we record, and let's go back to here and wait for this to start. It's doing its thing. And there it is. Okay, so we got that back, and let's do it again. Let's, like, now that we're recording, let's press the R button and do it again and see how long it takes. Well, that was way faster, isn't it? Look at that. I pressed the R button and it's frozen, but we did get something. We're getting something. It's just we're waiting for the regeneration to happen. So it's better. It's not waiting minutes, but we're definitely scaling a bit better than we were. Okay, so it's going to take some time for it to regenerate at this point. And it's stopped moving because as it's regenerating, it's doing a lot of background stuff. And one of the things is if I was to turn the profiler off, then the performance of this thing would be huge, way better, right, than before. But you can see now that it's back, right? So there's how it's back. And let's see what the performance is when I run around. I can still run around. I can still look around. I can jump. I can do all this kind of stuff. And you can see that I want to stop it where I get a bit of performance. Right, so I want to move, I want to jump, I want to turn on my map, I want to turn off my map, all this kind of stuff. And let's just stop recording at this point and see what's happening. So I'm getting a bit of this. And again, you can see that this is the drop. And just around there, if you look at what we captured last time, we captured kind of in the drop. So wherever we captured last time is what we want to do this time. So I want to capture kind of right in the middle of the drop, somewhere where there's a bit of a spike. So something like in here. So that's where I want to capture, right? And let's see the numbers that I'm getting here. 176.0 megabytes. Again, object count is 102,000 more objects than before. And we can see that the draw calls is about 5K and a bunch of other stuff. Okay, so this is where we're sitting. Let's do a capture and then we'll compare. So did we do better? Is the question. Did we do better? So control print screen, and just going to grab that, and we're going to say that this is after object pooling. So after object pooling. Wow. there's this. And let's compare this stuff with this stuff. So it looks like we were at 175 megabytes, 118.9 texture. We're back to 118.9 texture and 176 megabytes. So memory-wise, it's about the same, believe it or not, right? In terms of numbers of, look at that, numbers of objects, we only had 16,000 objects. Here we have 102,000 objects. So more objects, right? So that's more. In terms of our performance, what this looks like here compared to what this looks like here, it's a little bit better in performance. One thing to note is the draw calls, 5,000 draw calls. Here we had 4,500 draw calls, a little bit worse in terms of the way it was, but that particular test. 61,500 triangles, where we had 55,000. Well, because that's what we generated too, right? It depends on the generation. And 124.6K with 112K vertices. That's how we kind of captured before. So overall, not a great deal of change in terms of what we came up with. But in terms of performance, so if I was going to go back and let's just keep running, so we keep on profiling. In terms of performance for this thing, again, what I noticed is the actual time it takes for me to regenerate everything right here is, well, faster a little bit, right? So here's the way to test this. I'm going to stop doing this again. And one thing to also do is let's see if we get any more. I'm just going to go back to this. Let's go back to the next piece, which is I want to check in the console, and let's go into Open Editor Log. And if I go into Control F, can I still get to that build report? And yep, it's still there. We haven't done anything to address this part yet, but the first thing we did was capture that part there. So we haven't done an analysis. Let's see in the next change. Now we had our baseline. The right thing to do, by the way, guys, is only do one change at a time. So our baseline was about the same as what this is right now in terms of overall performance. I don't know if you guys saw the same performance when you guys did it. Yours might be different because, again, I don't have a lot of stuff in my scene. It takes time for me to generate it. And I get a performance hit in terms of rendering when I'm moving around. Again, but not much of one. Notice that I'm still hovering around 60 frames per second here after object pooling. When I'm running around here, I'm dropping still around, again, we're not cutting into, much. We're still about the same here as well. So again, not much difference in terms of from one to the other. Okay. Now, one thing we haven't checked is the report when it comes to our scripts and what the effect of scripts is going to be on this thing. But overall, what I notice is this: when I run it in editor, right, which is also something to note, it's different than the actual device. When I run it in editor, I get better results, right? There's a bit of a hop. You can see there's a bit of a hop when I change stuff. But overall, I can, kind of shoot this as many times as I want, and I'm going to get pretty accurate numbers, and the results are going to be pretty damn good. Okay. In fact, it feels more performant, but that just might be my bias. Okay, next, let's do another change. So one of the things that I thought about is, hey, what about, and we thought about this together, I think Herman and actually it was Liam last time that thought about this too. He said, hey, what about, can we not combine some of these colliders? Is it better to combine colliders into one big collider instead of having a bunch of these box colliders? What if we had like one big collider? Is that possible to do? And I've come up with a solution for you guys for that too. Let's take a look at that and see if it's going to help or if it's going to hurt. So that's the idea. The idea is I want to add, the ability for me to combine colliders. And what we're going to do is we're going to use this thing to combine meshes first. So if I look at Unity combine meshes, there is a combine meshes script that we can use, and they've given us a bit of example. I'm going to use almost the exact same script in mine, but this is the reference. I'm just going to copy that reference and give you that code. So what if I want to create a mesh, one big mesh, as opposed to little ones? Is that going to help? Let's see. How do I test that? So going back to Unity, and I wanted to prep. I want to go to my tile parent. It's my tile parent. And I want to add a mesh filter. Let's add a mesh filter. The mesh filter is going to represent the new mesh. It's going to point to the new mesh that I'm going to generate. I'm going to generate a mesh based on the meshes that I get from my tiles. I'm also going to make sure that the layer is the ground layer so I can move around. Save. Next, that's the only prep I need to make. Next, let's go back to the script. And in the script, now that we have those things in place, let's think about how this is going to happen and what I'm going to do. So yeah, so what I want to do is I want to make a brand new, kind of a method. I'll kind of put it at the bottom here. I'm going to call this method combine meshes. So I want to combine my meshes, and in this way, when I combine my meshes, I want to add a new mesh collider as well. The mesh collider will represent the collider for the entire world, as opposed to using box colliders, because there's a lot of box colliders. My thoughts are, let's make one big mesh collider. Maybe it's better. Let's see what happens. And I want to start off with getting a reference to the mesh filter that is in the tile parent. So I can say something like tile parent dot get components mesh filter. Okay, so that's the first thing. So there's my mesh filter. I want to say mesh filter dot mesh. That's going to equal to a new mesh. I'm going to use the initializer syntax here, where I say that I want to change my index format. This is an important piece that I found when I did this, to Unity engine dot rendering. I'll explain this in a sec. Dot index format dot UI. Notice there's two enumerations, UI 16 and UI int 32. I want to use UI int 32, which gives me more range from my indexing, because I want to have many, many more vertices than UI int 16 will hold. Okay, so the numbers are going to be bigger. So therefore I need a bigger range, and that's why I'm doing this thing when I make a new mesh. I'm going to also make a new list of mesh filter types, which I'm going to call mesh filters. All right, and that's going to be a new list of mesh filter. That is where I'm going to have all my mesh filters from my box colliders. All my mesh filters from the box colliders, right? So all the cubes, basically, from the cubes, the tiles. That's what I'm doing, right? Whatever the tile shape is, I'm combining that into one big one. All right, then I'm going to say for each, and we're going to do a for each for every tile in the grid. Every tile in the grid, I want to say, hey, mesh filters, let's add the tile.getComponents mesh filter. Let's add that into the mesh filters array list. And then, this is from the script that I got from Unity, I'm going to say combine instance. The combine instance array, right, is going to be called combine. And I'm going to say new combine instance array, and I want the size of the array to be our mesh filters dot count. So that's the size of the array. So I have enough. I'm going to use the combine instance to create my meshes. So it says struct used to describe meshes to be combined using mesh.combine meshes, which we haven't done. It's almost like a middle step. Okay. Then I'm going to say something like for while my I is less than mesh filters dot count. Then I want to combine, which is my combine instance. I want to say the mesh that I'm combining in here is equal to mesh filters I dot shared mesh. Again, this is coming right from our code online from Unity. And then I'm going to say combine I transform. We're going to get the transform from the mesh filters. And I'm going to say transform dot local to world matrix. Okay. And then finally I++. So this thing here is going to collect all the mesh filters that I want to combine and store them in my my combine instance array. Then I'm going to say mesh filter, not mesh filters, but mesh filter, the one that belongs to the parent, dot mesh dot combine meshes with my combine data, right? So this is going to create my mesh from all the mesh filters that I'm getting from all the tiles. That's what's going to happen. And then I want to say that my tile parent dot add component, and I want to use a new mesh collider. And great thing is mesh collider is based off of the mesh filter. Whatever the mesh that I have in my object, the mesh collider will be created based on that. Okay, so that's what combine meshes does. Right? That's excellent. But that just adds another layer that really doesn't do anything. So really what I want to do is I want to go over to my generate function, and I regenerate, I invoke remove internal tiles, and then once I've done that, I want to do another thing, which is I want to combine meshes. That's what I want to do, right? Okay, nice. Well, that's okay, but there's got to be some place where I remove all my box colliders at some point, right? And that's probably going to be in my remove internal tiles. So back into remove internal tiles, this one right here. So after I, kind of loop through all this stuff and I calculate all the tiles to be removed, then it'd be logical for me to sit there and say, well, now for each tile in my grid, then what I want to do is I want to destroy the tile.get components, and it's going to be the box collider. I want to get rid of that box collider from the tile, and that removes the box collider. So after I prune the tiles from the scene, then I destroy the box colliders from those tiles. That's what I'm saying. However, there's got to be a way of me returning tiles back to the scene, and then if I return tiles back to the scene when I reset, I got to put the box collider back. Because otherwise I won't have one. So, well, then in my release tile, if I go back to my release tile method, which is up here, then, well, release tile is going to put them back. And I say that in a weird way because it's like I want to do, before I on-queue it, I want to say tile dot add component, and I want to add component a new box collider. I want to put that box collider back. Okay. Why am I removing it and adding it? And why not? Am I not just turning it off? Someone might ask, right? Well, because it's still listed as a component. I don't want it as a component. I want to reduce the size of my scene as much as possible. So that's why I'm killing it. Okay. Not because I want to instantiate and destroy and create memory holes and all the other stuff, but I want you to think about me removing it and putting it back. But the problem with this release tile thing is when I release, what happens when I when I prune, right? Well, when I'm pruning, which is my remove tile functions, I'm removing my tiles and releasing it back first. When I release it back first, I'm adding a new I'm adding a new box collider. So there's two box colliders. That's no good. So there's two ways. Either I detect if it already has a box collider, or I move this function away. I don't move this function here. I move this function before I do all this stuff. So I say, hey, now that I've run through this and I'm removing internal tiles, let's get rid of all the box colliders, right? And I need the box colliders because otherwise I can't calculate the all of the normals, right? I need box colliders. So here I'm removing them all. And after I remove them all, then I release the tiles, and I release the tiles in a couple places, right? I release the tiles that I'm going to remove here. And then what happens is when they get put back, the box collider gets put back in for the ones that are released. The other ones that are not released, they're not going to have any box colliders. So that's going to be good. Okay. What about for my reset function? My reset function does some funky stuff too. Is there something that I need to do there, my reset map function, because I'm going through the map and I'm releasing my tiles, and well, yeah, there is something. I need to remove the mesh collider from the parent, because otherwise I'm going to have two mesh colliders. So I'm going to say if my tile parent dot get component, if I have a mesh collider already, then I want to remove it. So I'm going to destroy, just like we've done before, my tile parent get component mesh collider. Okay. So I got to remove when I'm resetting. If mesh collider exists, then remove it, because I only want to put it on when I need it. Okay. And I want to clear this because then it'll clear some memory as well. Is this going to work? And how is this going to function? Let's check it and see what happens. And then you tell me if it's going to be better or worse in terms of performance profiling. Have we made it better? Is it worse? Does it make a difference? You tell me. Let's run this thing and see what happens. So run locally, and sure enough, I get my tiles. I can move around nicely, no problem. And well, okay, what does this look like? If I click on the mesh filter, then you can actually look and see what the mesh looks like now. This is the mesh of my entire object, right? Take a look. Okay, it looks pretty good. Looks pretty good. But what does it actually look like in the scene? Okay, so let's zoom in. Oh man, that doesn't look right, does it? That looks like everything is still there. Why? Why is it still there? This should not look like that. This should look like there's only the tiles that are highlighted, but this is like, well, everything is meshed everything else. This isn't exactly what I'm looking for. What happened? What happened, guys? Why is it doing that? Did what I asked. I mean, if I run this thing one more time, let me show you. It did what I asked because all the tiles that are in the scene don't have their own they don't have their own box collider. So example would be this one here, right? Does not have a box collider. It does not exist, right? And well, wow, right? So I've actually done what I'm supposed to do. But the actual, tile parent itself, this tile parent here, it does have a box collider, and here it is. Oh, sorry, it does have a mesh collider, but it's just everywhere. Why didn't this work? Well, the short answer is, it's the same problem that we had before. I'm trying to combine meshes when I haven't removed my internal tiles fast enough yet. Again, I'm dealing with thousands of tiles to process. And these thousands of tiles to process, they're so big, they're actual objects, it's taking time. So we can do the same thing. And let's wait a few frames. Okay. Here we're waiting about 4 frames. Okay. Again, we can adjust these numbers. I'm just putting them down just for you to see them. So I'm combining meshes, but I'm first invoking my removing tiles. I'm waiting for this removal to be done, and then I'm combining meshes. Again, this is only happening once, so this invoking isn't going to cost a lot in terms of my performance, right? Again, we're talking about frames. Well, yes, because then we still have a bunch of tiles that are rendering inside when we don't need them. They're actually drawing everything. They have faces and materials and everything, right? And that's going to definitely be worse performance-wise. So let's run that. And sure enough, there we are. Okay, good. Still runs around. We still have a big collider. And what happens with our tile parent? Do you see any difference? Tile parent looks the same. It kind of looks neat from this perspective too. And what about when I run into it into the scene? Well, now it looks a little different. So when actually in the scene, well, this is what I was expecting. So that's what I wanted. Notice that now I'm only getting colliders, for the, for the tiles that are there, right? So that's the colliders made up of the tiles that are existing, not the other tiles. And okay, so here's another suggestion from Herman. We'll do that next, Herman. I like your idea. Herman says you could also put a mesh render on the tile parent before with the gravel cobble material, and then you don't even need the tiles to be active at all. Okay. Okay. I like it. Let's see how that works. Let's see if you can make it work. But first things first, let's see if this idea, let's do some profiling. Let's see if this idea worked for us, right? Or if it's a dud. Okay, so again, I'm going to file, save project, right? And I'm going to do the same thing. Let's go do a build and run. And let's see if our performance is better or worse than we had before. Okay. And let's see. What actually happens in terms of our memory. What are your thoughts, Herman? Do you think it's going to be worse for memory, better for collisions, better for physics? What are your thoughts? We're removing all those box colliders. We're doing that. They're gone, right? So what are your thoughts? Better performance, worse performance, the same? How about anyone else, or Michael or Mendy? Better for the update. Okay, let's see if you're right. Better, but I don't know by how much. Let's see. We're going to see by how much, if there's any better at all. Only one collider physics? Yeah, but what kind of collider do we have? We have a very complex collider. Remember, we talked about this before. I've always talked about this and said mesh colliders are way heavier, like far heavier than a box collider or a sphere collider. Yeah, we'll see. But these are like our attempts. We're trying to, I'm sorry, I'm probably going to spark out here. Let's see. Let's see. So again, hopefully you guys can hear me. So basically it's like this. The thoughts are making one big collider is better. But is it really? The nice thing would be, instead of us having all those different vertices in the mesh that we're creating, per facing, so if I look at the biome we've created, per facing, there's a minimal amount of vertices. So example, for the bottom, we could make it so that there's only 4 vertices, right? The whole bottom is a big quad. You could do that, right? Yeah, wait for a second and I'll go through it. It's going to wait till this is done. What I'm saying is it would be nice if the bottom of the whole entire biome has one big, it's like, it's the entire bottom piece is one big cube, right? That would have been nice. And then a kind of a, like a rectangle, almost like a rectangular prism, the bottom. So one big box collider, right? As opposed to many box colliders. That might be better in performance than anything else. Let's see how this thing performs. So ignore, let's turn this on, and let's see how this looks. So it's going to take its time generating. And let's see if it's better, worse, the same. So again, taking its time to generate. But remember what we want. We want to hopefully be faster in terms of how many seconds this takes compared to normal, right? In game, in editor, it's fast. But with the profiler, it's super slow. The reason why it takes so long with the profiler is because, again, we're getting a lot of little statistics and it's taking up a lot of processing power, from the actual device. Okay, there we are. So we're back. Okay, and we just want to move around. And let's take a look here. We move in here like this, and we move around. And you know what? We'll put on our map and kind of go like this. And so it's rendering nicely and excellent. And we'll jump around. And you know what? We'll stop profiling there. Hey, okay. We'll look for a dip like something like this, and we'll try and put our point there. There it is. And now we'll start looking at this and see if there's any difference. If there's better, worse, the same. What does it look like? Let's capture. So control backtick or control print screen. We'll grab that whole profiler window and bring it in. Okay. Go back to this. And we'll say, so this is after object pooling. And then this is in sequence. And this is after combining meshes. And what does this look like? So again, I ask you, was it better? Was the experiment a failure? Or was the experiment a worse? Let's take a look. So if you look here, it was 176 megabytes, 102,000 objects, and 118 megabytes for textures. 166 megabytes, 118 9, and 100K. It's about the same. In terms of its performance, though, it's actually worse. Take a look. See this, how it's approaching. It's filling up that 60 frames per second. And we have some spikes here that are in the 30 frames per second. But I have many more spikes here that are in the 30 frames per second, which means actually it's worse. It's not better. Look at this one. Here's our baseline. We have a few spikes that are in the 30 frames. When we did our object pooling, right, as an example, it's much flatter, but we still have the same amount of spikes. Not a lot of difference. But here we're clearly worse, right? Look how thick that is, right? So we have a lot more of these spikes that are approaching. And this bar, this area that's 60 frames per second, it's filling up. If it goes to this, that means we're actually going as low as 30 frames per second where all these spikes are happening. And from what I'm seeing from the capture that I got, we can capture it a couple more times, but you can see that this isn't as full as this one is, okay? And it's not nearly as full. I mean, this is about the same, I would say, as this one. So there's not a lot of difference between this one and this one, okay? But overall, here's our physics. Here's our physics. Look at this. Look at this physics stuff. This is like one continuous, kind of like, kind of thing. So that's interesting as well, right? Where I have the physics, the amount of physics memory is 9.4 megabytes, 9.0 megabytes, 6.8 megabytes, right? I mean, that again, this could be the stuff that we've generated too, right? So I got to also consider these things, right? And remember, we can capture multiple, we can do a few different samples. We've only captured one sample every single time. I could capture several samples for each thing to give us an idea of how this works. So if I go back and if I turn it on again, and let's do what you said, let's go and regenerate. So ready? Let's count. So I want to move around and press R. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 6, 7, 28, 29, 30, 31, 32, 33, 34, 35. We can actually do a timer too, stopwatch if you want, right, until we get it. But we're looking at like at least almost a minute now. It's going to come up to a minute in a second where, we're regenerating. Okay, there it is. Okay, so it took about a minute or so, and look, we're still not quite done. I'm still not able to move. It moved a little bit, and then it stopped again. There. And it crashed. Woohoo! Right? Look at that. That's not great. That's not great, man. Let's do it again. And there's a reason why it crashed. I tried to move before it was done, right? So let's just do a build and run again. Build and run. Nothing to build. It's going to build instantly. But let's see. And this time what I'm going to do is I'm going to time it. I'm actually going to set up a timer, or we're going to time how long it's going to take, okay? Right? Generating. You see a scene. This is faster than we had originally, believe it or not, still, right? And I'm gonna, after this, we're gonna capture it because I want to press the R button and then do the capture. Okay, I'm gonna listen to you. I love the idea, Herman, the mesh rendering thing that you mentioned. If you see a huge performance boost, I'd love to see that. Are you sure you were capturing? You're doing the profiling? Okay, there we go. All right, so there it is. So now we're good, right? And I want to press R and press the stopwatch and see what happens. So with everything that I got going on right now, I want to press R and the stopwatch at the same time. So R. Okay. And I'll tell you how many seconds it is approximately. I'm just going to wait here until we're done, and we'll see if you guys get any better rendering than I did. This is with the performance profiling running. So it's a good tool for that because you can see how many actual seconds it takes to do everything. Again, I'm just running a timer off screen here. It's going to give you more of an accurate measure. Okay, so far 52 seconds. Okay, so about 59 seconds, almost completely. So that's how long it took. And I'm in the middle of this thing somehow. Look, I rendered down in here. Why did I render in here? Because when I pressed R, this is another issue. when I press R, my player needs to be repositioned, and my player got repositioned before everything was generated. That's a problem. So again, that goes back to the whole invoke thing, right? So if I press R again, right? So here I am above the screen, right? And it should take me about 60 seconds approximately to generate. Again, big difference compared to the first time. The first time it took us minutes, right, to do the first, to do the first regeneration, right? So it's better. Object pooling helped for sure. When it comes to performance, object pooling was just way better than not having it at all, because we have all the tiles already available to us, and all we're doing now is regenerating. I'm going to go with what Herman's giving us as an idea and see if we're going to get even better than this. Okay. And then, cool, we're good. We've regenerated. We can move around now, and we're at the top, and we can see that we're not bad, right, for the second time around. Not bad at all. Okay, there it is. All right, great. This is okay. And what I want to do now, but about 60 seconds for the first time I pressed R. What I want to do now is do what Herman talked about. Okay, Herman, explain what you did. Maybe you want to come on the mic. It might be easier. So you went to the tile parent, and what you did was you added a mesh renderer, right? And then you didn't render anything in the tiles whatsoever, and you only rendered the mesh after we got the mesh. You added the mesh renderer. That's what you said.
So I attached the mesh renderer like in the scenes. Like right now, you would just put one right there.
Yep.
A mesh renderer.
Yeah, hold on. Here's a mesh renderer. Yep.
And then in the materials, you would put the material that you're using, the 3D tile, which is that gravel cobble ground material.
Yeah. That's the one. Did I make it so that? Yeah. Okay. Go on.
Yeah, and then in the script, what I did was I actually put the reset after the combined meshes. I don't know if my reset is a bit different than yours.
It might be. But anyways, let's see what you did. So you combine meshes, and then did you remove, or did you ever have in any of your tiles mesh render at all?
Yeah, they still have the mesh renders, but what I did was that I reset my map after combining so that all the tiles were just disabled and put back into the pool. So none of the tiles were active in the scene, just the combined mesh.
Oh, wow. Okay, I see what you're saying. So, okay, so let's say I combine my mesh, right? So you combine meshes and everything else. And after this, that's the only thing you changed was just to reset after? That's all you did?
Yeah, I reset after.
So hold on.
We don't need to reset before anymore because we would be doing it after. So all the tiles would be gone afterwards anyways.
Okay, hold on a second here. So we're doing this, release tile. And we're going to release them back into the pool?
Yeah, so what I did.
So there wouldn't be any tile. There wouldn't be any tiles anymore, is what you're saying.
Yeah, all the tiles are gone.
That's so interesting. And you're still going to have a mesh collider, and you're still going to look like something. That's so interesting. What a different idea. Okay, good. Let's do that. So let's not do that here, you're saying. Not do that here. You initialize, and then you regenerate. You remove internal tiles. You combine meshes, and then you reset? Like here?
Yeah, although since you're combining on an invoke, I don't know if the reset will.
We'll just invoke. We'll invoke as well. We'll invoke. We'll invoke the reset as well. Reset map. We'll do it so that it's like, let's say, a few frames after that, right? Oh, that's too long. So a few frames, a couple frames, right? So let's wait a couple frames.
Well, it would have to be longer than the combined mesh, wouldn't it? Then it would reset before the combine happens, and then it's combining nothing.
How's that? All right, so combining, and then we wait like almost 100 milliseconds, and then you do it. Again, we can wait longer if you want, but let's try this. This is 100 milliseconds. This is about 64 milliseconds, right? This is 100 milliseconds. Okay, so let's see if that makes any sense. So you're going to regenerate, you're going to initialize, and what does your reset look like? Is it different than mine? This is what mine looks like. Well, let's try it while you're looking. Is yours like mine, Herman? Your reset?
Yeah, my reset is just releasing the tiles, and that's it.
Oh, but you're not changing that. You're not. Oh, you can't kill the mesh collider, because if you kill the mesh collider, wait a minute. But you need to, don't you? No, because if you kill it, well, so when do you? You never kill the mesh collider?
The mesh collider on the tile parent.
Yeah.
Oh, I do that right before I although actually what I'm doing is I just keep the mesh collider there from the beginning, and then I set its shared mesh to the new mesh filters mesh.
Did I do something different here than what you did?
Just the part at the end. Instead of adding the mesh collider, I just have it in the scene already.
Oh, okay, okay. So what you do, just a moment. So you're saying in the tile parent, let's add in a mesh collider already. And then what you're going to do, let's move this up a little bit. Move up. You're saying that you're going to set the mesh collider's shared mesh to the mesh, right? Is that what you're doing? That means we have to get a reference to the mesh collider, which is the tile parents dot get components mesh collider, and you want to say, is it shared mesh or just shared mesh is equal to the mesh filter dot mesh? If I'm not wrong.
Dot shared mesh.
Sorry, yes, you're right. Mesh dot. Oh wait, you mean sorry. Mesh collider.
The mesh filter dot shared mesh.
Shared mesh. Yes. Okay, that makes sense because you're combining. And that's good enough. Let's see.
Yeah, that's it.
So you're not removing. Let's go back to that. I'm just make sure that I don't have that removal. I don't remove. I'm just releasing, and I'm clearing the grid. And then that's really it. We're using the grid just to size, really, at this point. So tiling is just for sizing, and that's it. Okay. Wow, that's amazing. Let's see if that works. So let's run it in the scene first and see if we get anything. And then we'll run it in the world. Wow. Okay. Wait, am I going through them? Okay, no. That's good. So let's see what this looks like. So then the, my map generator should have 0 tiles in the grid. Wow, what a difference, right? And what about if I regen? Okay. Instant. Oh, that's weird. That's because of this thing here is happening because of we need more time. So that means that in our invoke for reset map, we have to take more time to do that. So maybe another couple of frames. So maybe 128. So again, it's something like, instead of this is like 4 frames, another 4 frames, right? Yeah, the invoke is interesting, and you can also do something called invoke repeating, which is interesting as well. The challenge with invoking is that you're trying to control stuff manually, and that's not always a great idea. Wow, what a difference in performance, Herman. Huge. I can already feel everything, the camera and everything. Amazing. Okay, let's try it again. So we'll reset. See if we get any holes. I don't want any holes. I don't see any holes in the tile. Is that a hole? It's a hole. Okay, so we still need more time. Back to the scripts. Probably going to think about something like 200 milliseconds. Let's just put 200 milliseconds. 0.2. Again, the resetting of the map is the stuff that it gets released, before everything gets in. Actually, we might need to space out the removing and the combining too. What are your thoughts, Herman? How much time did you put in here? Did you put any time? You don't have any invokes. Okay. I think it's best, but only because it takes so much time. Do you get holes in your mesh or no? Huh. Isn't that interesting? It always happens on the R button. If you press the R button, that's when you get the holes in your mesh, right? So if you're going to get holes, it's going to be when you regenerate like this. See this? That hole is going to happen when you regenerate, right? And same thing here. And again, it shouldn't happen at all, but it does, which means we could wait around a little bit more between invocations. So maybe something like 1, and removing the tiles between regenerations because of the way it works. Maybe we'll do this. We'll do 1 and then another 2, and we'll say 3. So total of like maybe a second between invocations. But I'm doing that because I want to wait. Okay, we're generating differently. Still, I'm getting a huge performance boost. And I'm still getting these holes. Huh. Never had them before, but I'm getting them in a pattern, which is interesting. Look at this. Whoa. Okay. How are you generating differently? What are you doing differently than me? Again, I'm super impressed by the speed that I'm getting here, but I am getting these are artifacts. Yeah. Hard to test though. Interesting. It's not really something that I desire, but it's not terrible either. But it's like we did before. Okay, you're only generating the top tiles instead of creating tiles and then removing internal tiles. Okay, but all right, let's do something else to make it even more challenging for this thing. Let's go with a bigger number. So 64 tiles per second. And then I'll see what the difference is in terms of performance, because 64 tiles usually does a lot worse performance-wise than what we did before. Yep. Way bigger. So minimap wise, you got like a huge pattern. Look at that. Like a massive world right now compared to what we had before, right? And if I press the R button, we should get in real time. This is in the editor. 7, 8, 9, 10, 11. It'll be really impossible in the we'll be getting a lot worse in the there we go. So about like I would say 30 seconds. But it's also a massive world, like super massive. Okay. All right. So really great in terms of rendering. That's awesome. But then again, so the question is, if we don't need a renderer and all we need is a box collider, we don't need a renderer, right? Why even have one in the tile? I wonder if that would reduce the load when we first generate the tiles themselves. If I have less components, the idea is all I need is a box collider and a mesh filter. And if I'm not rendering, then there would be like that one less thing. So let's remove that too. So let's get rid of it. Remove. Let's suppose we don't even have anything to render anymore, right? Okay, so 3D tile only has a box collider. Well, I am checking to see how I can remove. You might not need it, but I do because I'm checking to see if I have anything in around me to remove all the internal tiles. So that's why I need the box collider initially, right? But otherwise, yeah, if you're doing it your way, you don't need it, right? Which is pretty awesome. Okay, so let's do go back to that map generator and put it back to normal, something that's reasonable. And now let's do some analysis of your method compared to what we did. Okay, so again, file, save project, and then build and run. Let's see what that looks like. And if we get any performance improvements the way I'm doing it. But I like your thinking. I mean, you're only rendering the top tiles, and inside you're not, right? So okay. But the great thing is it has they're tiling really well too. That's one thing about the mesh render. And of course, it would make sense because we have a mesh. We can use um, we can just render one thing. See if this works a little better for us. Again, I think you get the point of what I'm trying to do. Hey, Liam, how you doing? No problem, man. So Herman had this great idea, and I'm not sure if you guys can hear me or if I'm sparking out. It's a major rebuild. That's why it's taking time. And again, I'm just trying to wait till this is done. So even as an incremental build, it's taking its sweet time. Okay. And we're going to see the difference. It renders nicely. Cool. Let's do a regen. And let me just time it now after your optimizations. Wow. Wow. Look at these guys, right? That's incredible, Herman. What a great optimization you found. Amazing. Look at that. Look at the difference. 200 frames per second. We never got numbers like those before. So that right there is telling me that things are just way better. So, okay, let's reset the timer and let's just do the reload here. I'm going to press the R button and I'm going to start the timer. Let's do it. So remember, we had 60 seconds. That's how long it took the last reset, right, to work. 60 seconds. So, so resetting still takes a while because, again, we're regenerating tiles, we're removing tiles, putting them back, resetting up the mesh and all that kind of stuff. Let's see what happens here. So still about 40 seconds. Cool. So we saved about, I would say, about 13 seconds of time. So about 47 seconds before it reset. Huge, huge, guys. Absolutely crazy. All right, so let's do moving around and see what that looks like. And then, kind of do the same thing as I did before. I just kind of jump up and down. I turn the minimap on. I look around. I jump, whatever. And then I kind of hold the scene. And let's see what it looks like here. Wow, what a difference. Holy. That's insane. So the biggest hit it took is like right here, which is like kind of like this. So this is where it's at right now. And wow, what a difference. Look at this. Look at this. Look at these numbers here. That is amazing. You're right. It's huge. Okay, so let's do the same thing. So we will control capture. And let's do that. Awesome. And let's put that in there. So we'll say after, what do we do when we did, after we removed, or we used a single mesh renderer. If I can spell today. Huge. It's a huge performance boost, truly. So let's take a look here. So the big one is this CPU rendering. We're rendering at like mostly at 200 frames per second. Okay. 100 frames per second is like something we can hit as well on average. Some spikes are into the 60 frames, but nothing as bad as worse than that. So can you imagine, we were all in here before? That's where we were, way up here. And now we're way better, like orders of magnitude better than what we were before, because we got rid of all that renderer stuff, right? So a huge performance boost, huge. In terms of memory utilization, same. Memory didn't really change much. That's the same. Physics came up a little bit again, but our rendering, when it came to our vertices and all that stuff, and some of the things that we captured, that kind of went up a little bit, right? But in terms of, well, actually a lot, but overall, it was an amazing improvement over what we had before. Huge improvement. And one thing to also look at is, let's look at the rendering. So draw calls, look at this. This is the big one, guys. Guys, this is huge. Draw calls is 20. It's amazing, right? Compared to, look what we captured earlier. We got up here, look, draw calls, 5,000 when we started. That was our after object pooling, 5,000. Here we had like about 4,500, right? So the draw calls, guys, is the thing that really super improved our performance, like huge draw calls, right? So that is the thing. And triangles and all that stuff, like it just an amazing amount of stuff that happened. Okay, so like again, you're looking at like amazing performance differences. So awesome. So that's great. Okay, now let's do a couple more things. So we're going to stop this. So we won't stop this, but we will stop this. for a second. And let's just close this, and we'll close this. We don't need that thing for the number of tiles removed anymore. So where it says the number of tiles removed are, we don't need this debug log. We can see the number of tiles that were removed. We've got some pretty good thing with combined meshes now, and some other nice things. But what about our build for our, if I look at the console, it told us last time that when we went to our editor, right, it said that our build report was telling us that we had something like 9.7 megabytes in textures is the way of minimizing this, and there is. The way to do that, of course, would be to go to, I want to look at the textures that are big, right, that are giving us that information, and we got those already. It's way up here. The first thing we got was textures, and the big texture is this gravel cobble ground texture at 611 kilobytes, right? Okay, so what if we said for all of the textures that are here, all of them, right? So these are all the textures, not including the mini map marker and all this stuff, but the other textures. So all of this, not including this, all of this, we can say that, you know what, the maximum number, we want to override it for Android. So on the right here, you can see that we can override the texture for Android. And we can say that the maximum texture size ever is 256. Let's apply that change. So on Android only, we're not allowing textures larger than 256K, ever. That's like half of what we had before, right? And our default right now is 2048, right? Which is normal quality, okay? Let's build, because that was the big one. Let's build for our scene. So we'll say file, and we'll say save, file, save process. This is the last thing we'll do. And we'll build and run. And let's see if there's any differences now with our textures. If there's even better performance than what we got. Probably won't notice it, but let's see. So again, all I did was do an override. I selected all the textures, and on the right in the inspector, you can override the textures. You can also do it in the build, but I did it here because I wanted to show you that you could do it in different places. So again, not a lot of change, but the way it's building hopefully will be better this way. And this is kind of the last thing we'll try. All right. Okay, it's generating, and it's taking its time. It's going to probably take about a minute because remember the first iteration of our graph, our scene graph, takes about a minute to kind of generate because we're generating textures, we're removing them. Sorry, we're kind of generating our world and removing everything, and then we're putting everything in place. So about a minute. So if this is true, then we can do a lot of the similar work with larger types of tiles or even smaller types of tiles. So imagine if I change the tile size. Okay, so here we go. So let's see how the textures look. About the same, right? I don't see any difference. Do you? And yet when I run, I'm running really great. Even when I'm running and jumping and mini map on, and moving around. It doesn't really matter, right? But we can kind of do all the things we normally do. And if I was to go back here and do a capture, well, look, I don't even see a dent in what I did by moving around. Not like before. Before I was actually moving around. Whenever I moved, I would always get a dent in my rendering performance, right? So kind of like we did it, right? So if I moved around and then I kind of jumped around and stuff, I would get this crazy dent over here. I don't even know where to go anymore to look. There's no comparison. Look, it's huge. Okay. So that's what I'm saying. So now let's take a look at draw calls. Again, draw calls, 20 draw calls. And that's really, really good. Again, in terms of the number of, for textures, this is texture memory. Texture memory is still about what looks like 114, so it dropped a little bit. There's 114. If we stop this for a second, I'm just capturing just randomly right now. And if you look at our graph that we had before, so this is the what we had. Our textures were about 118. We've saved a little bit, but not much. Even when we reduce the size of our texture, it's like it was optimized already. Okay, and we'll just stop this. And this time we'll try and check out if our build is any different or if we're getting the same build. So again, I'm going to my console and going to my log. And let's see if we can find that build report. And about the same. So it didn't make any difference. And it could be because I need to do a rebuild, right? A lot of times that's what helps. I'm doing an incremental build, so there's no difference. So takeaways from this whole process. Hopefully you enjoyed it. The idea with this is that you can find little optimizations, and I think big optimizations was what Herman found. He found the biggest one. One thing that we can also look at, which we didn't look at today, if you go to project settings and if I go to graphics, we can look at URP and quality settings. Under quality settings right now, we're medium quality, but we're using this pipeline asset, and we have some options that we can select. So if I go to selecting the universal pipeline asset that I have, right? Because this pipeline asset is the thing that is really affecting my performance, right? Then we can look at quality, lighting, right? Right now, main light is per pixel, right? Shadow resolution. We can change all of these things depending on where we want to go with this. And we can look at shadows, and we can see that, again, we have one cascade, which is pretty good. That's a good thing. And a bunch of other stuff. Same thing with the rendering path is forward rendering, which is good. We don't want to use post or deferred rendering here. And yeah, the quality settings are huge. We can always look at those for to make improvements. Maximum shadow distance is 50. Again, reducing this and changing the cascade ratio and all that kind of stuff are things that you can improve or make worse by doing things. Lighting is a huge thing as well. And we really haven't touched upon lighting too much, but that is definitely something we can do. We can look at the project settings, quality settings, and see what we can do. The one thing also is that in our scene, our material that we're using, which is our gravel cobble ground material, we're using a universal pipeline Autodesk Interactive. What might be better than this is just using a basic material. So going back to a universal pipeline, render pipeline, a lit material like so. That might be better than using Autodesk Interactive because it's a lighter material. Sure. I'm not sure either. It's a lot better than what we had before, right? Because Autodesk Interactive is a bigger shader, and I have a feeling that if you switch to this, it would actually be even better. And you can test it locally, and that's all we're going to do. We're not going to go on further than this. Questions? Whoa. Whoa. Look at this. Look at this puppy right here. That was new. Yeah. Amazing. So really great performance compared to what we had before. All right. Let's file save and file save project. And I'm going to exit and put this up on GitHub finally. So on GitHub, here's section 401. Let's go to that one. Section 401. Here it is. I'm going to say added project files for Lab 9. This is just so you can see it as an example. It's not your Lab 9. Your Lab 9 has to be your project, like we said before. So please use your own project for Lab 9. See if you can find optimizations. Herman was able to find some for our simple project. Then there's a good opportunity for you guys to find stuff for your project. That's the idea. Okay, so try and do that. I'm just going to kind of close this off, and we'll also say updated the profiling report. So the profiling report will be included. This kind of idea is what we want with more detail. You can also include observations and a bunch of other stuff. Yeah, you need a video too. Like I want you to go through it and show me the differences. So what about if you're already optimized? So this is one thing that people always ask. I'm already optimized and there's nothing I can do. I've already got an object pool. And that's kind of the stuff that we were talking about this morning is, well, what about trying it without the object pool? Remove the object pool and do an instantiate and destroy and see if what the object pool would have given you, has given you. Like show me the differences. That's something you can try and do. Prove to yourself that the object pool is working the way you think it's working, right? But the things to look at are audio for sure, UI. If you have audio and UI, definitely things like your rendering. The biggest thing is textures, lighting, all those kind of things. Particle systems. Those are all things that you can optimize. Some thoughts were if things are far away, call your camera early so you can only see a certain distance, because the more backface culling and all those kind of optimization techniques are the things that you want to use now, all right, especially with mobile. All right, and what I'm looking for is see if you make any changes. Make a report. If there's no change, say, look, we've optimized. There's nothing. We've tried running the profiler and we get no difference with all the changes we've made. Okay, so try and look at all those different pieces and see what you get. Any questions around this before we go for the day? So again, thank you so much, Herman, for all that great suggestion. And I'm looking forward to seeing you guys next week. Any questions before we go? Thanks, guys. Take care. I'll stop recording now.